Okay, guys, today we're going to look at transformations part one. So, part one encompasses exploring vertical transformations. Okay, so if I'm given this graph, I can look at my coordinates and figure out my points, correct? So remember, each one of my points is going to be here. So because of that, I can fill out my table. So if I go over to f of -4, remember this is representing my x. So because this is representing my x, if I go see what is going on where x is -4, what my y value is, I will get a 3. So if I'm looking at my -3 where x is -3, x is -3 here, so what will my value be? That's correct, 0. And where x is -2, what is that value? So go ahead and finish filling out your table. Pause the video if you need a minute because I'm going to show the answers. All right, so that's what we should have gotten for our y's. So when I plug in, remember you're looking at your x value to figure out what your y value is. So I'm looking at this x value to determine what my y value is. Don't get confused on that. Okay, so now I'm taking my y value and I'm adding 2 to it, correct? So I'm going to take my y value and I'm going to add 2 to it to see how that changes things. Make sure you understand that. Make sure you understand what you're actually adding 2 to. And if you're confused on where to find this on your sheet, just turn your paper over. It's on your second page of your sheet. So let's talk about what this looks like. So we're going to create a table with the domain and range values. So here's my table. And I know what my f of x values are because I can turn over my sheet of paper and look at the ones I just wrote, correct? And then I want to change that by 2. So when I do that, I'm going to write my original range values here for f of x, which is the 3, the 0, the -3, and so forth. And then if you look at it, I'm going to add 2 to that actual f of x. So that's going to be my new range value. So all we did was add 2 to each one of these terms there. And now I want to plot those 2 points. So my original x value is here. My new y value is here. So those are the points you're going to draw. So I'm going to go over to -4 and I'm going to go up to 5 and plot a point. And it'll look like this. That's the original. So now when they change each of those points, watch what happens. When I plot my new points, do you see how that shifts everything up to? Make sure you understand that. So what I'm saying is by me adding 2 here, it shifted my whole graph up 2 units. So the function has a vertical translation by 2. So now what do you think is going to happen here? Now I want to subtract 2. So what can you hypothesize is going to happen here? Some of you are saying I think it's going to go down by 2. Let's take a look. So again, I'm going to do the same thing. Wait a minute. There's no table here. I have my original graph, right? So why do you think it stopped me from going to a table? Because it wants you to build up on the prior knowledge of what we just saw happen a second ago. So if I plot my 2 points, I automatically know it goes down 2. So don't get confused. We could have went over there and did the whole table, but it's showing you based on the fact that you know now it's going to shift down 2, I can take each point and just move it down 2. So let's look at the next one here. And now it gave you the tables. Now you can go back and figure out your table. So this function had a vertical translation by a -2. Good job. Remember, if you don't understand or you're still writing it down, just pause your video. So now I want to put a 2 in the front. I want to multiply by a 2 and see what effects it has. So what do you think we're going to do? That's correct. We're going to start with our original. So the first thing I want to do is I'm going to create a table with the domain and range values. So there's my table again, and I have my original x, and now I want to look at my original y. So those are my original range values. So now, what do I want to do with those numbers? That's correct. I want to multiply them by 2. So I'm going to do that to get my new range values. When I multiply that by 2, that is what I get. So now I'm going to plot the points. Remember again, I'm going to use my x and now my new y to plot those points. So there's my original graph. And now I'm going to plot the new points, and that gives me my new graph. What do you think happened there? Okay, I'm hearing different things. I'm hearing some say, Ms. Head, it stretched up. Some saying it pushed in. Let's talk about how we word that. The function has a vertical dilation by a factor of 2. So don't get so caught up on was it a compression or was it a stretch? It is a dilation by a factor of 2. You should write that on the summary. So now, we want to look at what is going to happen when we take the range and multiply it by a half. So what do you predict is going to happen? Okay, so how am I going to figure that out? Where do I want to start? Okay, I can go straight to plotting the points. Can't I take half of each one of those points? If this point is 3, I know it's going to be 1.5. Half of 0 is still 0. Are we clear what we're doing here? If I take half of that, half of this point, and half of this point. So the function had a vertical dilation by a factor of a half. Good job. So what if I multiply it by a negative? What if I put a negative in front of it? We're on actually number 5 of your notes. What do you predict is going to happen if you multiply it by a negative? So again, we have my original function. Look what happened. If I take a positive number and multiply by a negative, it's going to flip downward. If I take a negative number here and multiply by a positive, it's going to flip up. So what I really have is a reflection over my x-axis. So the function has a vertical reflection across the x-axis. Good job. Now remember, if you ever need to stop during one of my videos, you just pause it. Don't think, okay, I need to write faster, Ms. Head is talking fast. You just pause the video. So now I'm taking the absolute value. We're on number 6 now. I'm taking the absolute value for a function. So when we think about absolute value, we know absolute value is the distance from 0. So it's really not measuring the positive or negative. It's giving me a positive value. So what do you think are going to happen to my negative values here? You think they're going to become positive? Let's take a look. That's correct. So do you see this piece down here that was negative? And this piece down here that was negative. It reflected upwards and became positive. And if it was already positive, it stayed positive. So the function has all the negative y values reflected across the x-axis. So anything that was a negative, remember we talked about positive and negative in the last direction, it reflected it up to make it positive. So what's going on here? With this one, it's like we're multiplying it by a -2, and then we're going to subtract 1 from that. We're multiplying it by a -2, and then we're going to subtract 1 from that. So what do we think is going to happen here? Okay, that -2 we dealt with before, and we saw that it did what? Okay, we saw that it did a dilation, and then what did the 1 do? Okay, what you're thinking is, Ms. Head, when we did it a second ago, it was inside the f of x. We didn't deal with anything outside the f of x, and you're correct. So this is where we're going to stop, because this is actually getting you into the exploring horizontal translations. And we're going to talk about that next time. So remember, watch this video over and over as many times as you want, and I'll see you in class. Have a good day.